All right, ladies and gentlemen, today we're going to be looking at your section 10.1 through 10.4 mixed review. This will help you on your quiz tomorrow. There are several problems that are pretty basic, remembering your skills about exponents. So on number 4, the way that we taught you again is to take the coefficients, which is the number in the front. So the 2 is going to multiply by the 4, which is going to be an 8. But if you notice, looking at the variables again dealing with the exponents, got a little tiny ones here. You need to remember that even though it says multiply, you're actually just putting your variables together. So off to the side, you remember a squared, that's really written as a. And then over here, you have a to the first power, so it's really an a. So one way is writing them out and seeing how many you have, or using your rule, which is adding your exponents. So a would be a 2 plus a 1, or writing them out, you still get a 3. Same thing with the variable b. I have a 1 plus a 2, which is really a single b, and then a b, so it's a b to the third power. So again, the key is your coefficients in the front, the numbers in the front, they're going to behave like normal, just a normal multiplication problem. But your variables with the exponents, either write them out and count them up, or remember your rules. All right, looking at number 10. This one, you have two ways to complete the problem. The first one is your rules, of course. The rule is saying that the exponent outside is going to be distributed or given to each item inside. It's kind of like the distributive property in a way, but dealing with your exponents. So the 2 is going to get the power of 2. Your x is going to, so actually already x squared, is going to get the power of 2. And the trick I tried teaching you guys is the inside-outside. If you have an exponent inside and outside, you are going to multiply them together. Same thing for my y. Inside, outside, multiply together. So this is your first way, your rule way. 2 squared is 4. Your exponents will multiply to get your answer. Oh, I'm sorry, that's supposed to be a little 2 there. Let me use my eraser. And that will give me a 6. If you did not like that way, or you can't remember, am I supposed to multiply? Am I supposed to add the exponents? The additional way is saying, okay, my parentheses with the exponent outside being a 2 really means write the parentheses twice. So now it looks like a problem really that we just spent a moment on, problem number 4. Even though there are parentheses, it really means it is a multiplication problem for your coefficients. So therefore, 2 times 2 is a 4. And then for your x's, you can write them out. Remember, x squared is really xx. X squared is really xx. You see 4 of them, or you can remember the rule that we did on the previous page again, is adding your exponents. So a 2 plus a 2, and then my y is a 3 plus a 3. Or you can write out 1, 2, 3 y's, 1, 2, 3 y's. So you write them out and you count them up, and that's how we get the 6th power. So you've got some choices that you need to make. What is the best way for you to complete this problem? Can you just do the rules like I mentioned on the left side? Or do you want to adjust it to make it a little bit similar to a different rule, or that whole writing out process, which will still get it either to the correct answer, but sometimes it's not very helpful. Again, depending on the size of your exponent. If it says like x to the 14th power, you really don't want to write out 14 x's. So that's one way, or one time you really need to know the rules, is the size of the exponents. All right, let's jump to number 18. Number 18 includes a little bit of information that we didn't see on the previous problems, which includes an exponent of 0 and a negative exponent. In reading the instructions, like what we've talked about in class, all of your answers must only have positive exponents. So if you have an answer with a negative exponent, unfortunately that is incorrect. All right, so a variety of ways that you can do this. Let's see. what I'd like you to do maybe is to think about only concentrating on half of the problem first. So if you have a card, a straight edge, a bus pass, something like that, we're going to go ahead and temporarily cover up that side. So on the left side, I need you to make the decision on what you are going to do. For this problem, I'm going to show the rules. If you would like to make it similar to what we did here, where you write stuff out, go for it. That'll take you a little bit of time. All right, so this is a -4 to the third power. So the rule tells me the negative sign also gets the third power because the negative sign is inside the parentheses. The x cubed gets the third power. The y cubed gets the third power. So really, I'm just simplifying the left side, and then I will go to the right side. So the rules, even though it may be a little bit more complicated for students to remember, it will actually save you some time, and maybe, therefore, it'll be a little bit easier to complete. So remember, your power of 3, -4, multiplied by -4, multiplied by -4, gives me -64. Then I have x to the 9th power and y to the 9th power. So the left side has been simplified. Now I'm going to go ahead and simplify the right side. I'm going to use the same technique. But if you know on this one, the 0 power, remember that really doesn't matter because anything to the 0 power is really just a 1. So I'm actually going to go ahead and say I can cross that off because it's just a 1. 2 times 1 is just a 2. So I'm going to say 2 to the 2nd power. And then y negative 1st power multiplying by the 2nd power. Again, inside, outside tells me to multiply. So this really gives me 4, and it gives me y to the negative 2nd power. But as we're trying to see here again, a negative power we don't like. So what this really becomes is the 4 stays the same, but the y becomes a fraction. So the y actually goes to the denominator with a positive exponent now, and you really have a 1 at the top. Or wait a minute, can I just say 4 times 1? So I'm just going to say that's a 4. There we go. Or you can erase that if you like. All right, now to finish it off, I'm going to go ahead and put it together. So let's see here. I'm going to bring this down a little bit, just to make it a little bit easier for you to see. And since it was a bunch of parentheses, it's really multiply as well. Ooh, look. There we go. All right, to complete this problem, I notice that I've got a -64 multiplied by a 4. So that's a negative sign. If you have to, you go to the side and do 64 times 4. Some of you can do it in your head. So -256. Now the x's are going to stay the same, but I need to reduce my y's. And the thinking, if you remember, so if I put it together, it's really y to the 9th power over y to the 2nd power. This is going to lead into another problem that we'll see in just a few moments. This is another rule. You can do it 2 ways. The first way, again, is the subtraction of exponents. Or if you really wanted to, you could write out 9 y's at the top, 2 y's at the bottom, and cross out what they have in common. But that's probably too many y's than you want to. If you can remember the rule with the subtraction, it's a lot easier. So the y to the 7th power would actually be at the top because the 9 is at the top, or the numerator. So do I even really need that fraction sign? No. I thought I did, so I got it ready. So again, a lot of steps involved there. That would be one of the more advanced problems. So again, on your quiz, if you get stuck on a problem like that, you skip it and you come back to it. So keep that in mind. All right, looking at this one here, kind of a combination of the problems that we just talked about. Let's see. The -2 gets the power. The x gets the power. So inside, outside means multiply. So 4 times 5 is 20th power. -2, and again, you're going to really think about this as a bunch of -2's multiplying together. Maybe you remember the trick again. If the negative is inside with an odd exponent, that will stay a negative sign. If you need to, you come over here to the side and you write out a bunch of -2's and you multiply them together. -2 multiplied by -2 is +4. Another +4. And then I got a single -2. 4 times 4 is 16. Multiplied by the -2 is -32. Inside, outside for the exponent means multiply. If you really wanted to, you could have written your parentheses a total of 5 times, kind of like what you did over here. And that way you would really be adding up all of your x's instead of multiplying. But notice the amount of work that that's probably going to take. So if you can remember the rule, again, it'll make life easier. All right, this one here is kind of going back to what we briefly talked about on number 18. If you have the same variable, top and bottom, all you really have to do is subtract. Since the 14 is the larger exponent, your result will be at the numerator. So 14 subtract 7 is just a simple 7th power. But again, since it's at the numerator, it's going to stay at the numerator. If there was a bigger exponent at the bottom, just a little side note, let's say you had x squared over x to the 5th power, you would still subtract, but it would actually be at the denominator. So what would be at the top then? Simple 1. All right, we just did 18, 23, 26. Now let's look at 27. So number 27 is kind of a slightly more complicated version of number 4. The coefficients in the front again, you're going to keep it multiplying. 7 times 6, just a basic multiplication. Your x's, they are the same variable, so that means I can combine my like terms, which is really addition. So a -8 add 3. So I have 42x to the -5th power. Now again, on this one, it's very similar to what we saw on number 18, is the negative exponent we do not want. So we're going to leave the 42, and then the other one's going to become a fraction. So the negative exponent, again, the trick, the rule is make it a positive exponent by really just changing its location. So this would be considered kind of like at the numerator, so we're going to put it at the denominator. And a 42 multiplied by 1 is just a 42 over x to the 5th power. So again, using the rules, trying to keep up. All right, the next one's going to get a little bit more complicated for number 32. I really selected this one to help you out. So what I would suggest on this one, there's a few ways to do it, but if you want to just keep consistent with what you've already done, each item gets the exponent. So that means I have m to the -1st power multiplying by the -3rd power. Remember, the little trick is inside-outside exponents means multiply. The m gets the exponent, so I'm going to multiply it again, inside-outside. Same thing with my denominator. So it's really just the distributive property. All right, simplifying this. M, and then I got a -1 multiplied by -3, so that's the positive third power. This one here gives me a -15th power. And then this one here gives me a 6th power. Now, from here, you actually have multiple ways to do it. I would probably suggest maybe kind of like that separation idea. What if you were to look at the numerator? The numerator is really similar to what we just talked about here, a -8 and a 3 for the powers or exponents. So I'm going to say, if I were to add those together, that would give me a -12th power from the numerator. Okay, there. Now my denominator was really just a 6th power. So I'm going to skip that middle one, and I'm just going to go ahead and bring it down here. It's not a negative exponent, so I can just go ahead and keep it there. All right, so I'm running a little low on room, so let me slide it or put a new slide. That is m to the -12th power over m to the 6th power. All right, so as we stated, we do not want a negative exponent, so we can't stop here. So what we're going to do again is think about this one having to change. And if I do that, the changing of location really tells me that it needs to go from the numerator to the denominator. Now this one, the m to the 6th power, that's already a positive exponent, so it could stay the same. And if you remember from one of the previous problems, you got little ones at the top. Putting it together, again, a 6 and a 12, that is using addition. Which is really 1 over m to the 18th power. Again, a lot of steps involved there. A lot of the rules. All right, let's try the same thing on, well, actually 35 is probably an easier version of that. So what you need to do again is think about the items separately. So if I look at my coefficients, I have a negative divided by a negative, which is a positive. 48 divided by 8 is a 6. Then, now that I've looked at the coefficients, then I could look at the variables, specifically the c's. So if I have a c squared at the top and a c at the bottom, which is really a first power, the rule again is subtract. I'm going to subtract at the numerator because it's a bigger exponent there. So that's really just a 2 subtract a 1, which is obviously just a 1. And the last one, I have the 5th power, subtract a first power. So really don't need the fraction line again. So my answer is 6c. I don't really have to write the first power for my answer. And then d to the 4th power. So again, the coefficients behave like normal, so you're just going to do basic division. And then the variables using the rules. A lot of little different rules to have memorized. All right, just a few more to help you out, and then you'll spend some time on your own. Looking at 37. Again, a lot involved here. So on this one, it might actually be easier for some students to simplify inside first, then deal with the exponent outside. And one of the reasons I'm suggesting that on this problem is because if you notice, we've got a lot of different pieces going on. So that's what I'm going to do for this problem. So I'm going to keep it the 4th power. And then inside my 12 divided by 3, that's just a 4. My x's, I don't want the negative exponent at the bottom, so I'm going to change its location, which tells me to put it at the numerator. So at the top, I already have an x. At the top, now, I have an x squared. Putting that together will be an x to the third power. The y gets to stay where it is. And then the z, I don't want it with a negative exponent, so I'm going to change its location, and that's going to go to the denominator. So a little bit of cleanup, x and x squared, that's really x cubed. So I now have 4x cubed over y to the fourth power, z to the fifth power, and then a big power of 4. So this problem is now just a little bit more advanced form of number 10, maybe even 23, where again, each item is going to get the exponent outside. It's kind of like distributive property. So that is 4 to the fourth power. Excuse me. And then for the variables, remember it's inside, outside, so that means I'm going to go ahead and multiply my exponents. Again, the little rule, the trick is inside, outside, multiply. So the variables are actually the easier way for students to get the correct answer, especially if it were to be like a multiple choice question. But do you remember the mistake that I have mentioned a few times about my coefficients? A lot of students, for whatever reason, they do not use it as a power. They just went ahead and multiply it. So for example, like if it said 3 squared, they would say that that is 6 because they do 3 times 2. That's incorrect because we know that 3 squared is really equal to 9 because it's 3 times 3. So got to be really careful with these coefficient and then the power. So again, remember that means 4 times 4 and then another 4 times 4, so 16 times 16. And if you remember, that is really 256. 16 squared is 256. All right, everything has been simplified. I am good to go there. All right, few extra problems at the back. Critical thinking, if you will. Look at number 42. Number 42, we have given you x squared and x to the fourth power. So it's just a really basic problem to begin with. If you combine this, it's really just x, and then we got to add them up. So that's going to be x to the sixth power. So what I need you to do is to look at those options and see which other ones will also give you x to the sixth power. So let's see. Answer A. Answer A says x to the 16th power over the second power. And if you remember on this one, you're really just supposed to subtract. And if I subtract, do I get the 6th power? No, that gives me the 14th power. So unfortunately, answer A is false, not correct. All right, look at D. Oh, actually B, my mistake. I have 2x to the 8th power. Well, really, that is already simplified. There's nothing you can do there, and that is not x to the 6th power, so it is not answer B. Look at C. Now remember, C, the rule is inside, outside, multiply. So if I were to multiply those, that would give me x to the 9th power, which is not x to the 6th power, so it's not answer C. All right, so I've got a few more choices. I got to find out which one gives me also x to the 6th power. So letter D. I have a 4x over, wait a minute, can't I reduce my 4 and 2 just like a normal problem? Yes, I can. So that means if I do 4 divided by 2, that gives me a 2. Does my answer start with a 2? No, so really there's no point in going forward on this. I know it's not correct. All right, look at E. E tells me that I have an x over an x to the negative 2nd power, and then outside is a power of 2. All right, so inside, if you remember, we don't want a negative exponent at the bottom or anywhere really, so we have to move it to the new location, which is at the top. So really, inside x and x squared, that's really a 1 plus a 2, so that is x to the third power. Ooh, do you see it? Inside, outside means multiply. And 3 times 2 is x to the 6th power. I've got my first answer. Maybe there's another answer. Not guaranteed, but most likely it is. So using our awesome testing skills, we're going to look at letter F. And this is kind of like a duh. Yeah, of course it works. X to the third and x to the third. That's really just a 3 plus 3. So yes, that is an x to the 6th power. So I have an additional answer. But again, notice how I went through each one using the rules that I worked with previously and found 2 answers. All right, then you got a few error analysis, but I'm going to look at 46. 46 tells me to explain with work and words. So for example, when you guys were doing your performance task, many of you on the ice cream question performance task, I should say, many of you were able to do the math, but you did not explain with your words very well. So let's see. First of all, is this true? So, that's an addition sign. A little bit different than what we've been seeing before. So 3 squared, that's a 9. 3 to the third power, that's a 27. Oh, I see what they're asking. So they're saying, since it's an addition problem, not a multiplication problem, am I really supposed to take my exponents and add them to give me a 5? That's what it's asking. So right here, a 2 and a 3, does that give you a 5? Well, yeah, of course it does, right? But if you notice, it's really supposed to be a multiplication problem for it to work. That would work, not the addition problem. So you can go about this a few ways in explaining it. You could say, due to the property of exponents with multiplication, I would be allowed to add my exponents 2 and 3 to give me an exponent of 5. However, since it is not a multiplication problem, it is instead an addition problem, I am unable to use that rule. Therefore, I worked it out using my order of operations. 9 plus 27 is equal to, and then over here, you could really just say, okay, it's a bunch of 3s. And we know that 3 times 3 is 9. Got the single 3. 9 times 9 is 81. And right there, you already know it's not going to work. But again, with the proving it, so I've got 243. 9 plus 27, does that give me 243? Of course it does not. So, a variety of words that you can use, but I think we were primarily getting at with the rules with our exponents. You can add your exponents if, and only if, it is a multiplication problem, right there. Where on our current problem, it was addition. Sneaky people. All right, last one, number 48. I have it already set up for you. It says a computer in the 1980s had approximately 2 to the 18th bytes of memory. Today has 1 gigabyte, 2 to the 30th bytes of memory. How many times more memory does today's laptop have than the computer from the 1980s? So, since it's a real comparison of this, it's really just a division problem to find out how many more times it has. And the rule again says if it's the same base of a 2, I can simply subtract my exponents. So it's 2 to the 12th power greater. And if you wanted to multiply all those 2's out, you can do that. But if you notice at the bottom of the worksheet upside down, number 48 says, ooh, it's about 4,096 times greater. That's a lot of memory compared to 1980s computers. You have no idea what it's like to work on a super slow old computer. Well, maybe you do. All right, ladies and gentlemen, you have an excellent review worksheet here. Spend some additional time working on the problems. This is due tomorrow. Have a quiz tomorrow. Be awesome.